Thank you again so much for joining us today. On this session, we're going to be talking about helping customers use GitLab for deployment. So I want to turn it over to Darwin, and probably need no introduction, but thank you.
Thanks, John. Everybody hearing me all right? I will start my screen share here and we'll dig right in. It's typical of me, especially when a presentation is brand new, to have an utterly overwhelming amount of content. So I apologize for that ahead of time. Okay, so it wants to show over here. Gotta get these two aligned here. All right, so just quickly, a few things, kind of a heads up agenda. We'll try to go through with clients being a trusted advisor, not a pundit. And I think this is important in this area to understand where GitLab's strengths are and where it kind of trails off. Also, we're going to talk a little bit about mutable versus immutable stacks, what they are and kind of how they came to be. We'll talk about integrated deployment as a service. So this is something that I think is typically missed in a lot of conversations with customers, is that there are integrated deployment as a service capabilities in certain places. Kubernetes is one of them, which has brought this to the fore, but there are others. And so we kind of have to have a bit of an understanding of that. We'll talk about endpoint management for mutable compute. So compute that cannot be simply replaced. What are some of the endpoint management challenges that we run into, and why does this become a challenging issue for customers who have this kind of compute and are trying to use GitLab? And then finally, we'll do mapping customer infrastructure and app deployment needs to GitLab. A couple of apologies. It's a complex product area, and also there's a lot of products and methodologies out there. Also, GitLab's deployment automations are nuanced, and initially they have been Kubernetes centric. The customer's deployment automation maturity and tooling must be taken into account. I've taken the liberty of stretching the original ask at immature customers, because I feel like we have a lot of potential to misstep here for all of customers. So I just wanted to make sure that we kind of get a handle on all of it. And at the end, we have kind of a decision tree that handles the mature versus immature customers. And then I usually try to make my presentations more visual, but didn't have the time on this one. Just a bit of background about myself by way of introduction. Most of my career has been in the area of mass provisioning and deployment automation, including designing endpoint management systems, endpoint update automation. I've worked with a raft of technologies and multiple methodologies in this area, and have done some kind of thinking about what fits where and why. So as opposed to just taking all the technologies or methodologies that are out there and just kind of, oh, we can mash them up any given way, there are certain attributes that cause these to be built in the way they are. And so it benefits to understand what underlies it. A quick note about being a trusted advisor, not a pundit. When I'm working at GitLab and I hear someone say, oh, well, that's not the proper way to do microservices, or that's not the proper way to do X, Y, or Z. Well, I understand that there's a kind of usually manifestos out there that define exactly how you should do it, just like the Agile manifesto. There are many valid and sometimes invalid reasons for customers to pursue patterns that aren't what we consider best on point. So it's important to not just opine the primarily or only the greatest and latest or the best practice. So you don't want to be so strongly dispositioned on that you don't fundamentally see what the customer has that's different. There's also natural limits on the applicability of new practices to systems built with previous methodologies. And as we all know, tech debt's a real thing. Customers can't, pull themselves out of the mud overnight, even if they have an application that could benefit from that. There's also real and substantial cost to modernizing, especially for its own sake. And then also keeping in mind that when you work in this industry, you have greenfields all the time. You stand up a brand new cluster and do some stuff on it. The cluster's bad, you just delete it and do another one. Customers, usually their world's the opposite, especially in production. They can't greenfields it. Production is not completely immutable, that they can blow it away and recreate it in minutes. And then the characteristics of some systems mean that the in-context best practice might be an older practice, even if it's a brand new system. So it's actually the system attributes that dictate whether it's best practice to be immutable, mutable, or some sort of hybrid. And so it's important to understand that the best practices apply to the pattern of the application, not the current calendar date. So it's really important to understand, why is your customer doing what they're doing? Then sometimes they can articulate that well, and sometimes they can't. You want to be careful about assuming that if they can't articulate it, then it's irrelevant, or it's unchosen, or it's not a characteristic that needs to be maintained. So sometimes customers can't tell you why they need to patch production instances, but when you dig into the details under the covers, you find out why they have to, even though they can't necessarily tell you. So Pundicity is for marketing, and some of us do both, right? You do some marketing, you talk about best practices, best patterns, but trusted advisorship is for clients. So when you get in front of a client, you don't want to be giving them all the latest stuff they already heard on the best practices that they can't get to for some reason or another. So just a note about handling these situations appropriately when we're in front of customers versus marketing. So mutability, there's a video out there by HashiCorp that's really good on mutable versus immutable. Basically, mutable means changeable. So the ability to change things, or the necessity to be able to change things, and immutable means unchangeable. So in the case of infrastructure, we think of updating existing compute with new application binaries versus completely replacing those compute units with a pre-configured new set of binaries and configuration. With mutable, some of the attributes that are typical are the multi-purpose stacks, so monolithic stacks. They're sharing resources centric. So the whole reason we had shared compute, whether it's on the mainframe or your desktop at home, is because of the need to share resources. You don't want to have 5 computers at home for 5 different purposes. You want to have one shared compute. And at one point, hardware was very expensive compared to today. So that was another reason to share compute. With mutability, state and data remain in place. So they're on the device. So that's a concern that has to be handled during updates. Mutability usually requires patching cycles. So we have to maintain the software and the operating system that underlies the application. So we have that attribute. Updates can be smaller and more bandwidth efficient. So when you send 5 patches to a machine, it's a lot less bandwidth than sending a whole new machine or a whole new machine image. There is a hybrid that's very common on the web. We externalize our state and data, and then our compute is mutable. So if you think of a web server farm that's on classic instances with operating systems under it, generalized compute, but there's no data on them and there's no state on them, so that if one terminates, a new one spawned and we're good to go. So this is kind of a hybrid. It's semi-mutable, but the operating system has not been refactored to take account for the fact that we have a very single purpose stack. And then you can do immutable deploys to these using entire machine images, which is kind of like treating entire instances like they're a container by replacing the entire machine. Then we get into immutable. So single purpose stacks are the way here. They tend to be application centric. So the whole stack exists for this one application or application component. It creates predictable tested configuration. It does require entire machine replacement cycles to do updates, whether you're patching an OS, so you have container OS vulnerabilities, or any other kind of update. It also requires an additional envelope release cycle. And I'm not a fan of these when they're not necessary, but you get your software ready, you test it, and you say the software is ready for release. Now you have to package it inside of another binary asset, which you also need to test and release potentially with a separate version number because it encloses your actual software assets. So this can be a downside depending on the situation. Updates tend to be large. So if they have to be pulled across bandwidth, low bandwidth connections, then that's a challenge, or paid bandwidth connections. And it can be expensive for non-actively developed systems. So if a system is sunsetted and the only way to patch it is to send out new binary machine images every month instead of just running a patching cycle, then it can be more expensive. And for a lot of teams, it doesn't make sense to tell them, well, just re-release your entire stack every month for patching when the software has not been updated in 2 years, because it doesn't need to be, or it's on its way out. Is this just a deployment concern? Absolutely not. So whenever developers develop, they develop against an assumed baseline, and this has been the ongoing contention between dev and ops forever, is what's the assumed baseline, including runtimes, versus what did I build it on versus what am I deploying it on? And so this is very much a development concern. If you build immutably, then you're expecting your baseline to be perfectly exactly what you spec and nothing else. If you build for mutable compute or shared compute, then you don't have the same guarantees and it becomes more challenging. So quick quiz. If you haven't looked at the slides already, is physical hardware deployments, would you guess them to be immutable or mutable? And you can just shout out your answer. If you have one, or I'm not monitoring chat, I should be monitoring chat.
Mutable?
Mutable, yes, mutable. So physical hardware, you got an OS on there. There was some systems way back in the day that could make them somewhat immutable, where you could restore a snapshot of a physical machine from another hard drive partition. Some of you may have reset a machine to its factory deployed state with something similar. What about virtual machines? Mutable or immutable? And it's okay if you guess wrong, or you can take contention with whether it's wrong or not, whatever you guess. Virtual machines, I give them a on immutable and think of them as more as mutable. You can do implementations with virtual machines that make them more like immutable compute, similar to what we talked about with the hybrid. What about cloud instances? So we're talking about instance-based compute, a full operating system standing on an instance.
Mutable.
I think it's implementation specific. So if you have an ASG in the AWS parlance, an ASG of AMIs that you roll the whole AMIs every time, you're basically got mutable compute, or immutable compute, sorry, even though you've got, it's kind of the hybrid there. Containers. And mutability, you can think of it as if it terminates, will it have its state when it restarts? And immutable, someone guessed, Edmund. And oops, hey. Okay, yeah, sorry. So that's kind of the state of immutable and mutable compute and kind of how we got there. As stacks specialize and compute specializes, we want to be more and more sure to that stack, and the stack gets smaller and smaller and more purpose specific. If you go look up Amazon Firecracker or QEMU, ChemU, I don't know how people say it these days, but virtualization, we go and throw the OS out and we compile our application directly against virtual hardware. So we're even throwing the OS right out. There's not even a container OS. There's not even a LAMP time. There's just you and the virtual hardware. Integrated deployment. So integrated versus external deployment. So in Kubernetes, we see integrated deployment right into the cluster orchestration. So we send Kubernetes a command and it will upgrade our cluster or deploy new images or deploy a brand new image or namespace based on traditional IAC DSL with the deployment manifests. When we have external deployment for mutable environments, it's a very heavy lift. So if you think about products that put an agent on every endpoint and then have a management station, and then you send patches and you send software and you monitor what's on them, that's a very heavy lift doing external deployment for mutable environments where state and data are changing. Travis DPL abstracts various deployment technologies, but it does not provide IAC for them. So this is an example, and we actually have a page on our website that says use Travis DPL as a possible deployment capability. However, it's just an abstraction layer. So the customer or whoever's using it still needs to know the underlying stuff and have built their system based on CloudFormation or Google's engine or Azure Resource Manager. So it just abstracts the deployment piece only. Now, AWS has what I'll call a super catalyst strategy. They've been building and giving away deployment as a service integrated for long before Kubernetes was around for all of their computing, what I'll call fabrics. They're not technically a fabric as in hostless, but all application infrastructures are fabrics where you can deploy your applications to. They're highly mature. So there's advanced deployment patterns such as Canary and Gradual. They have auto rollback built in. They're as a service, so they're completely scalable. If you think about the runners for this on Amazon, there is no runners. It just runs in the cloud when you do this. For us, when we run a deploy, we have to have a runner somewhere or a scalable runner farm. They're permissionable. They're IAC driven by default. So it's all driven by CloudFormation, or if there's a sub involved like code deploy, they have their own domain specific language. So some examples: code deploy. Amplify has built-in deployment. Amplify is a quick way to build mobile-based apps. SAM, quick way to build serverless apps, abstracts certain things away for you. Big contrast, VMware is just virtual machine infrastructure. There's not application fabrics, at least not to my knowledge, built right into vSphere. There's no load balancing, no update applianceware like there is in Amazon. So when you get into VMware, there's usually another product involved to manage that. So integrated deployment as a service. For physical hardware, do we have integrated deployment as a service when we have physical hardware, or external? It's going to be external. So you don't really have management systems. The exception might be Intel with BIOS updates. You might be able to get as a service built in if you have all their hardware on your physical hardware. Virtual machines. Just type your answers into chat. We have external deployment as a service. Cloud instances. Any guesses on cloud instances? Cloud instances can be either way, depending on how you implement. So they're kind of a hybrid here as well. So if you have AWS ASGs with code deploy, you can either update applications or replace the entire farm with images, so you can create basically an integrated plan. Docker containers, oops, animation's off here. Docker containers, external. So when you get Docker, you get an immutable stack, but no deployment services. So you got to implement a cluster orchestrator. Swarm, Mesos, or the one that's really become de facto is Kubernetes. And Kubernetes is a total solution, which is allowing you to do the orchestration as well. So real quick on endpoint management for mutable compute. And this is why it's tough if you have immature customers who are deployed, say they got web servers, they update by hand, was one I heard recently. And so the customer's like, well, hey, how do we do this in GitLab? So endpoint management for mutable compute needs an agent to be effective. At GitLab, we don't make endpoint management agents. It requires a management system to deploy and track deployment status. It's also a heavy lift to keep that agent installed and healthy everywhere. So I've been in organizations, we have 100,000 endpoints, and you have 10% that are unhealthy at any given time just because of sheer massive scale. There are many mature systems out there. It's a massive product category. Updates can break due to unexpected state and data, because remember that state and data is on the compute nodes, and so updates can end up breaking you. Desktops are the worst case, but they're also a lesson for back-end compute. So desktop computing is where there's a ton of data and state change all the time, done by users. Plus, you're not supposed to interrupt them when you go to do updates or to try to clean things up. Infrastructure environments, something to keep in mind. Everyone's like, infrastructure is code, infrastructure is code. Great, but there's not always 100% immutability possible. So if you have a PayPal endpoint that comes into your system, you have to be able to make sure that that same PayPal endpoint is attached to the right environments. You might have other things in the environments like RDS. You stand up a massive RDS cluster to be shared. You're not wanting to restand that up every time someone runs a pipeline because it takes too long and it consumes too much compute. So they can't always be completely immutable. Also, this is a big one. Infrastructure as code that's engineered for bootstrapping is not ready for continuous updates. So sometimes people think infrastructure as code's magic. If I deploy with infrastructure as code, if I want to add 5 nodes to a cluster, I just put 5 and shove it. That might be true for some simple updates, but unless you've tested and engineered your infrastructure as code to allow changes, then it may break the next time you try to update something with it. So this is important because it's a step of maturity for customers and for us in order to have infrastructure as code that's truly update ready, where you can update any part of the infrastructure and have it push through and do an in-place update. So GitLab Deploy. Auto DevOps deployment derives a lot of its value from Kubernetes. So if you understand the development of GitLab, the initial part of all of our deploy functionality was 100% Kubernetes. You could, as far as what's kind of out of the box and constantly demoed. Now customers can build their own deploy, no problem. But a lot of the way we think about deploy comes from Kubernetes roots. So it's inherently abstracted from the underlying cloud or virtual infrastructure. So by being on Kubernetes, we automatically, it doesn't matter what cloud you're on, whether you're on hardware, whether you're on VMware, if we're just having to interface with the Kubernetes control plane, we don't care what's under that line, which is not true of other kinds of compute. It's inherently immutable. So it's containers. So the way to update Kubernetes clusters, replace all the containers. If you're like, oops, I got to roll back, you replace them with the old copy of the containers. It's inherently immutable. It inherently has integrated network security partitioning, network and security partitioning, or environment partitioning. So you can easily deploy environments into Kubernetes because it's a concept in Kubernetes. If you go into Google Cloud and you do managed instance groups, it's up to you whether you create them in environments that are separated from each other by security and networking, or if you put them all in one big blob. So there's not as strong of support and strong of an opinion on that within other kinds of what I'm calling application fabrics. Inherently has integrated deployment as a service. So that's a big part of the value of Kubernetes orchestration, is to have that concept of deployment as a service. So these are not direct GitLab attributes. And this is where sometimes I think folks get confused, is that these are attributes of GitLab Deploy versus these are attributes of GitLab integrated with Kubernetes Deploy. So that's, I think, an important understanding, is that this kind of update capability is really when we hook up GitLab to Kubernetes. So non-Kubernetes in GitLab, GitLab is embracing some cloud-specific integrated deployment as a service technologies, mainly in AWS, and we'll talk about them in a minute. GitLab does not do management agents for endpoints for mutable compute. My opinion is, nor should we ever. It's a huge and massive rabbit hole if you step into it thinking it's going to be easy because your experiences with immutable compute. The other general rule is when deployment as a service exists for a fabric, you should use it. So if you're deploying to a certain kind of cloud infrastructure in Azure and they have free deployment as a service built in, you would typically use it because of it's scalable, it's got security, and all the kind of similar attributes that Kubernetes has. Terraform and Ansible are gaining market momentum and GitLab momentum when building IAC from scratch. So if you run into a customer where they're going to go completely from scratch, then around here and in the market, these two, Terraform does cloud pieces and infrastructure pieces, and Ansible does endpoint configuration and management if necessary. So let's look at some GitLab deployment examples. Physical hardware. If I have a customer who comes to me, and I had one just recently, physical hardware, they're embarrassed, very embarrassed in sales meetings, but GitLab doesn't really have a direct solution for that. So whatever they do today, or implement a third party. If what they do today is a bunch of shell scripts, that might be possible to integrate that in GitLab. You'll find a place on the GitLab website that says, create a shell script that remotely reaches out to all the systems and does a pull onto that system. There's no status updates on what's going on. There's all kinds of challenges with doing something that simplistic that are the same as the person running around and updating each machine by hand. So I would advise them it's time to invest in a third party. If they're doing virtual machines without any kind of management infrastructure, same thing. Do what you're doing now and put it into containers, even if that's like hand scripts, or by a third party. One thing that's interesting is if they are doing stuff by hand right now, they've probably got all the security boundaries and login permissions worked out, which can be a challenge in a net new environment. So if you do a net new clean cloud environment, and all of a sudden you're saying, oh, we need to SSH to every machine or RDP to every machine, there's a whole bunch of assurances you have to do around network routability, firewall openings, as well as services running on the target clients. So if a customer is already doing hand scripted management, there's a good chance all that's open. So that's one plus if they have to implement what they're doing today as GitLab containers. And basically I tell customers, I ask them, do you do it in a container today? Or do you do it at a command line interface today? And if they say yes, they say, well, then we can do that in GitLab, whether it's on a shell runner or a Docker runner. AWS Kubernetes, or any Kubernetes, but basically you use GitLab Auto DevOps with Kubernetes integrated. And so this is our most fullest solution. Actually, this shouldn't say AWS here. I'll remove that out of the deck. But any kind of Kubernetes, use GitLab Auto DevOps if it's greenfields. AWS Docker for ECS. So this is AWS's container orchestration that predates Kubernetes and is kind of an alternative to, say, Swarm. So then we are building out or have started our first MVC on using GitLab Auto DevOps. Now, interestingly here with our Auto DevOps, other than Kubernetes, we don't necessarily have status coming back. So you can't go to the deployment panel and find out how many instances have been updated out of how many total are in the cluster. AWS EC2 instances coming soon. So this is also using code deploy. So notice we're tapping into integrated deployment as a service when we do this. And this is, in my opinion, the right thing to do, because we don't want to have to build a scaling runner farm just to accomplish deployment to 5,000 instances. Now, if they're in VMware, maybe they do want to do that. But otherwise, we leverage what is out there. One thing too about runners is we don't have any meta controls in our pipelines. So in code deploy, it's services talk to each other using messages services. So there is no container running somewhere during a deploy, where with us, we have a container running and it has to stay open for the entire deploy. And in some big instances, this could be like 2 days to get the status back or continually repeat the status. So when you can use a scaled cloud service, a lot of times that concern of meta automation is handled. AWS Lambda. If the customer wants to use Lambda, they could use code deploy. We don't have this wired up to GitLab Auto DevOps. AWS Serverless, use server application model, which is another abstraction over CloudFormation and code deploy. That's an easy way, and this is how Amazon promotes to developers how to do serverless, because they're trying to basically make ops and deployment be a non-issue for development teams. Like, they don't need an ops team. So if you use serverless application model, the beauty of it is on a command line, you say add RDS database services, and it goes chunk, 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 added to your project. And when you deploy it, it deploys RDS for you by magic. So all of these are meant to kind of encapsulate ops. Now, as companies grow bigger, their application is huge, they usually do need ops specific skilling and attention. AWS Amplify is another one. This is for building mobile apps very rapidly. It's another one where at the command line, you say, hey, I need Cognito mobile authentication services. Enter one command line, it adds a bunch of junk to your source files. You deploy it again, and boom, it goes up. Interestingly, in this one, I should indicate this here, Amplify, you can now use GitLab as a deployment source. It's the only place in Amazon that I know of where you see GitHub, Bitbucket, and GitLab right side by side is on Amplify Deploy. So that's kind of a view of where we're at. Other cloud infrastructures are not as mature, but as they mature, we can start embracing their stuff as well. You'd have to talk to the group that works on Deploy to really get a feel for where they're heading with some of this. Any questions on this part? I was very concerned that I wouldn't have time to get through all my slides, so now I've I've got a few more slides, but I just want to pause and ask about questions or thoughts or counterpoints or counter thoughts. Quiet crowd this morning.
Darwin, my only question is, so are you saying AWS Lambda and serverless, we have no GitLab capabilities, or is this just?
So yeah, but they also have a CLI. So you can just fire up a container with amplify CLI on it. And by the way, I've got in guided explorations under containers, I've got a repo that has a whole bunch of Amazon CLIs as containers. So the amplify one is there. So you would just, as the last stage, and I think I'm going to cover this in a minute, as the last stage, you would simply fire up a container with amplify CLI on it and say, my repo's here, it's got all the source files, deploy that into Amazon. And what we don't have, and we'll be seeing in the following slides, is status feedback from that. So you can still deploy it, but you'd either have to have a container sit there and pull that service. You could sit there also and pull that service with the CLI and say, how's my AWS serverless or amplify or Lambda code deployment going, and get status feedback and emit that to a log. So you just need one container to deploy it, one container to monitor its status on any of these and any other cloud.
Can you get a link later for that one, for that amplify?
It would basically be like you'd say AWS Lambda deployment or code deploy deployment command line. And you would see that, okay, you would create your code deploy archive. And then on the next command line, you would push it up and tell your Amazon code deploy application, they call it, to run an update with that new revision. So it's bespoke marked to each of these fabrics. So what I would call these fabrics down the left-hand side, it's not the proper term for fabric, but just they represent a computing infrastructure which has certain behaviors. And then when they have an automatic deployment service over it, your customer would have to sit down and look at, okay, how do I push a deploy, and then how do I monitor? We can create guided explorations for these, and we do probably have more around code deploy. I don't think code deploy has status monitoring yet, but it's easy to create something, and if you have a customer that needs it, that can be created potentially as part of a POV.
Thanks.
Any other questions or thoughts? So one of the reasons I wanted to go through some of this immutable infrastructure, the challenges of mutable endpoints and managing them, is that this is like, if you're not careful and you're advising a customer on deployment, you can easily step off a cliff or walk them off a cliff because of these various attributes and the complexities of what kind of compute they might be deploying to. It can also inform you steering conversations or GitLab implementation or GitLab POVs a certain direction. So for instance, they're like, hey, we've got a new team deploying to Kubernetes, and then we got all this old crusty compute, on virtual machines or something else. Then you can advise them to POV on Kubernetes and let them know that whatever work has been done to deploy to those other environments will need to be integrated into GitLab. So mapping GitLab to customer scenarios. Let's say the customer is targeting Kubernetes. If the customer's green fields are just getting started with Kubernetes, then it's reasonable to steer them to GitLab Auto DevOps and do it within a proof of value. I will caution you that true multi-container microservices is something that we don't have patterns for. So Auto DevOps does assume one container in one repo, and that when it builds, there's not built-in capability to wire it to other containers that build out of other repos. So just be aware that out of the box, when you're demoing Auto DevOps, it is not showing a multi-service microservice. If they already know and are using Kubernetes deployment directly, so they're like, you say, oh, what are you doing for deployment? They say, we use Helm and kube control. You want to be careful about implying that's a real simple, easy fit into GitLab Auto DevOps anyway. Definitely it's more compatible, but they might be doing some very opinionated things in there that they've developed over time. So it depends how long they've been doing that and how mature they are with that, whether you want to imply or position that for auto DevOps. Now, on these slides, I have post POV, paid POV. You could also be pre POV. My assertion here is that if a customer starts putting this kind of criteria into a POV, I call that a productionizing POV, because this is work that normally might take their people 3 months to figure out, and you just stuffed it into a 1-month POV, hopefully hoping. And so I always try to be aware of when a POV criteria is productionizing. And if I had my druthers, I would make it a paid POV every time, or tell the customer, once you figure that out, come back and we'll POV GitLab. Because if they're saying they're POV in GitLab to figure out whether GitLab's the right solution, but we have to make absolutely sure it seamlessly deploys with this big production opinionated system we've built, then you're potentially lining up for something that could be a really long and heavy lift. Now, in enterprise, that might be completely okay. In commercial, you have to be really careful with the customer size and deal size justifies heavy lifts like that. Oops, sorry, went backwards. Then using a third-party deployment solution in front of Kubernetes, then I would just say they can then decide whether to integrate that with GitLab. So there's like Argo CD can deploy to Kubernetes. So you're kind of putting a deployment system in front of the built-in deployment of Kubernetes, just like we do with GitLab. So you want to be sure that if they have a really opinionated use of that product, that you're careful about implying that it should be a direct swap. They should take consideration. If they say they just barely implemented Argo CD like 3 months ago, well, that's a different case. So GitLab supported non-Kubernetes or GitLab Auto DevOps. So this is basically right now that's AWS, ECS, and EC2 is coming. If it's greenfields, use it. So if they don't have anything right now, then go ahead and see if they can use GitLab's ECS or EC2 support. If they're already using Auto DevOps integrated service, so they have extensive use of, say, ECS. They've been doing ECS for 5 years. Be careful about implying GitLab's ECS support built into Auto DevOps would be a great fit for them, because once again, they might have very opinionated ideas about how that should happen. And these two are early days for us. If they're already using a third-party solution, which can have a whole raft of issues wrapped into it. So some third-party solutions would be, if you've heard Argo CD, you've heard another one on the Windows side is Octopus Deploy. These have environment management capabilities built into them, because remember, they're not in the deployment fabric and the application fabric. So they a lot of times will have very complex config data management built into them. And we can do some config data management, but it's not a direct user experience. So just be careful if they're using a third-party solution. You might want to suggest that they think about integrating with it, especially on the short term. And then if they want to consolidate over time, as they get familiar with GitLab, then they can start to take the metaphors and the work processes they've built into this third-party tool and fit it into GitLab as they become more familiar. But once again, you don't want to try to do that fitting during a POV, in my opinion, or not one that's going to fit in 30 days anyway. Non-Kubernetes application fabric has an integrated deployment as a service. So this would be Azure Resource Manager, and it has deployment as a service built in for doing the equivalent of ASGs in Azure. Then integrate it with GitLab. Mark, to your question, many times this will be, you can do this in a POV because it'll be 1 or 2 CI jobs that basically, and the customer probably already knows how to do it. They just need some encouragement to do it in a container to hand that off to that service, and then another container to collect status if they want status back. They're already using an integrated deployment as a service, integrate it with GitLab. Wait a second here. Oh, okay, so greenfields, if they don't have anything, let's say, and they're trying to manage EC2 instances in Amazon, you would suggest code deploy and then integrate it with GitLab. So rather than suggest doing scripts or even Travis DPL, I would suggest, hey, learn code deploy, get it moving, and then integrate it with GitLab. Using a third-party solution, suggest that they could potentially consolidate into the vendor's deployment as a service to have complexity and cost savings, but don't try to do that as part of the POV. So let's say they're using Octopus Deploy and then they're deploying to Amazon and they're wanting to save the Octopus Deploy cost. You could say, well, you might be able to move to code deploy at some point in the future, but you don't want to try to put that in scope in a POV. No integrated deployment as a service available. Greenfields implement a third-party product and integrate with GitLab. So let's say they got a whole bunch of Windows machines on VMware and they're managing it by hand. I would tell them, you might want to think about using Octopus Deploy and integrating that with GitLab, because that's going to give them the environments that we have in Kubernetes. That's going to give them a lot of the complex data configuration data management. If they're already using a third-party product, just tell them to integrate it with GitLab. If they want to consolidate, you should tell them it's probably best to integrate first and then consolidate later as you become more familiar with what GitLab can do. One anti-pattern, using traditional endpoint management to manage cloud public apps. So if you get a really unusual organization, they might be trying to use, maybe they have very strong traditional IT, and now they have a customer-facing application on the web, and they're trying to use something like Microsoft SCCM to manage, a web app or a scaled app. That's an anti-pattern, and you should generally encourage them to not do that. But if they're already entrenched and got it working, you may also just want to leave it alone. So that's it for kind of what I have prepared to handle this topic. The greenfields is kind of the original ask. So wherever you see greenfields on these last two slides, that's the original ask of what if a customer is brand new at something, then take a look at the greenfields items here, and that will give you an idea of what you might advise them. So I'm sorry it can't be a simpler story, but it all depends what kind of application the customer is moving, where they are in maturity with already managing that, whether it's with products or their own engineering capabilities against something like Amazon, and where GitLab is with what it can do out of the box and what it does not do out of the box. Thoughts, questions, follow-ups?
Very quick question, Darwin. Ignorance here. What is a post POV? I've never heard that.
So I'm just saying after the POV.
Oh, after the POV.
Yeah, it's not an event, but just say, hey, we could do that POV, or we'd encourage you, if you've proven GitLab is what you want. Now, if you obviously you're an enterprise, if you have a massive customer and they're looking at a $5 million deal and and they stomp, well, then of course you do what you need to do, right? But generally, if you're thinking of a POV as validating whether GitLab's the right solution for the customer as a primary thing, then you want to be careful about getting too many of these deployment specialities wrapped into that POV, or at least account for it being.
Got it. So not doing all the work, basically.
What's that?
Not doing all the work, not doing everything.
Well, even if you don't do the work and they do the work, it's going to extend the POV because their engineers are going to have to understand how do we do this and all of that. And so I call this productionizing POVs, where they're trying to take production concerns and work them into POV. To me, it's kind of like getting professional services for free when they wedge that in there.
I get it now. Okay.
Yeah.
Thanks.
Cool. Well, if anyone has questions about deployment automation as it relates to GitLab or a customer, let me know. I know this is a little bit AWS centric on the virtual/cloud side, but also AWS has two things that are the most mature cloud, and they've approached this idea of deployment as a service built into their fabrics fairly aggressively. So even other clouds that are mature may or may not have gotten this idea that we need to put deployment as a service built in to fuel, basically do a catalyst to get more compute usage. So they've been pretty aggressive at this before even Kubernetes came along.
So where's GCP at in all this? Close? Way behind?
That's probably a question for Kurt or Mayank.
Okay.
They are, I know that, like, for instance, I found a comparison of their Spot Compute to AWS Spot Compute, and their Spot Compute is not as suitable for runners because it has a required termination in 24 hours. 30-second notification from the time you're notified till they terminate the instance forcibly on you. And they also had, it's fixed price. So that's why they're forcing you to terminate every 24 hours, is because they can't change the price without you terminating and restarting. And where AWS has made it more fluid than that. So it's a true compute market. And so there continues to be detailed attributes about certain parts of cloud infrastructures that make it suitable or not suitable. So I'm not sure what some of the other clouds are with deployment as a service built in. As I'm in alliances now, I'll probably get more brush up against that, and I'll automatically have some curiosity about understanding that portion of other clouds. But right now, I'm not the guy on that. Sorry.
Fine, thanks.
So, Darwin, bit more of a great presentation, by the way. Learned a lot from this, so thank you. From a sales perspective, why would a customer want to talk to us about this? What is it that we should be focusing in on?
I would say that teams, like I'll give you an example. A startup going to Kubernetes is prime for auto DevOps because they don't have a lot of opinions about managing a cluster. They don't have a lot of opinions about deploying to a cluster. They would love one tool. So that's an example of like an auto DevOps to Kubernetes perfect case. I think a lot of customers that are really deep into already integrated deploy as a service are going to look at what we have and assume that they're not going to be able to get out of it what they need. When they just look through our demos and our panels, they're going to be like, well, you know, or they're going to assume that all that stuff comes back from AWS because we don't distinguish on the website, you know, this is awesome for Kubernetes and we can, you know, you can make it work yourself for other infrastructures. So I think the other thing is to be careful not to confuse Kubernetes attributes with GitLab deployment capabilities. On a positive side, GitLab has a strong concept of environments, which is important for any kind of deployment into anything. And this is something that someone building something into anything can leverage. And if they really study into it, they're like, oh, so I can take the concept of an environment, throw that into my infrastructure as code, which is some silly thing we haven't even heard of before because it's brand new. They can still use a lot of those capabilities, but they're down to the learning curve of getting to know GitLab and all of its hooks for deployment, and then implementing that in their own system. So I think, yeah, be careful not to confuse GitLab's overall deploy capabilities with how well it works with Kubernetes, because that was first and foremost for us. And then be careful about customers who do have experience with deployment about your implications that they should use GitLab instead. And then always be hopeful that whatever they're doing now, they can integrate it with one or two jobs. A container that has, you know, even Terraform, most of our Terraform integration is a container with Terraform on it. You run various stuff. Well, almost anything else that's truly infrastructure as code that you can run at a CLI, you could do that in GitLab too. So on that side, if they've got capable engineers, just tell them, yeah, do a container to deploy it and another one to monitor status if you want to see a static status. I'm encouraging the group who builds deploy that we should build a mirror the status of all of these other deployment as a services back into GitLab. So it'd be really cool if when we deploy to code deploy, we get back the list of instances so we know how many there is, and we get back at some frequency every 5 minutes how many are done and how many are in progress and how many are dead and how many are, you know, so we could pull that back and represent it in deployment. So hopefully one day we'll start to get more of that, but it's going to be a build. If you see what we talked about, because we don't have the Kubernetes control plane in that case, it's a build for each one of those, right? So if Google has theirs, AWS has theirs, someone else has theirs, it would be a custom build to get that status back.
Thanks, Darwin.
Yeah.
All right, we're at time, team. Thank you so much, Darwin. Great presentation. We really appreciate it. And I hope all of you have a wonderful day.
Take care, everyone.
Thank you.